Okay, so this is part 5 of this proving trig identities that I've been working through with you. I'm going to put down a couple other examples that we haven't seen before, so using a few other tricks. And as I'm writing this down, I just want to say that if there are any particular examples of this that you want to see, please send me a comment and let me know. And in the same way, if there's any particular math concepts or math areas, topics that you want to see discussed, send me a comment about that too. All right, so here we have, they look very similar both sides. Okay, they both have something that's squared and something that's to the exponent 4. Doesn't matter which side I work with. So let's say because I'm always working with the left side, I want to work with the right side. So I'll write right side equals. So I have cos squared x plus sine 4x. All right, it's always easier to go from something that has a higher exponent down to a lower one. So I'm going to break this guy down. Okay, so the first thing I'm going to do is I'm just going to rewrite it in a different form. So we have cos squared x, and this is the same thing as saying sine squared x, sine squared x. Okay, and notice what I want to get to. So I'm working with the right side. I want to get to the left side. I need to bring in a cos 4x. So that's what I have to keep in my mind. All right. Then at this point, let's change this one. We can give it another name. Okay, this would be cos squared x. So I'm just bringing this term down. This is sine squared x and 1 minus cos squared x. Okay, so we have that. Okay, at this point, let's expand this. So this will give us cos squared x plus sine squared x minus sine squared x, put that in there, cos squared x. All right, now, let's notice something here. I really want to keep this one because that's already sitting over here on the left side. So it's the other stuff that I need to work with. When I focus on the other stuff, notice how we have a cos squared x and a cos squared x. We can factor this. So let's take that out. So we have cos squared x. So remember where it's coming out of. It's coming out of this one and this one. If I take cos squared out of there, that's a 1. I take a cos squared x out of there, it leaves me with minus sine squared x. And then write this one down, the plus sine squared x. Keep looking at that other side. Remember, I want to get to, I've got my sine squared, it's already there. I need to get to a cos 4. Well, this has another name. It is cos squared x. Keep this. And then when you have a squared term times another squared term, this becomes cos 4x and then plus our sine squared x. And if we take a little look, that is our left side. Okay, so we started with the right, we moved our way down to the left. Okay, so what I'm showing in this example is when you're dealing with higher degree functions, so we had 4s on both sides and we had squares on both sides, play around with the 4, okay, the higher degree. Easier to go from a higher degree down to a lower one. All right, last example that I'm going to do, and again, as I said, if these have helped, that's great, that's the intention of this. If there are examples that you want to see, please just send them to me, write it in a comment, and again, if there's any other math topics that you want to see discussed, send me that as well. All right, so example number 2. Now this one is going to involve a little technique that you may use in many areas of math. So let's put down this example first. Okay, so we have 1 minus cos x over sine x, and we have sine x over 1 plus cos x. All right, now do not fall into the trap and look at this and say, oh, that's sine x or something like that. No. Okay, we don't know what 1 minus cos x is 1 minus cos x, the same as the 1 plus cos x. If it was 1 minus cos squared, then I could change that and call it sine squared, but it's not. Okay, left side, right side, they're both equally the same. Let's go with the right side again. So it's sine x over 1 plus cos x. All right, so the technique I'm going to use in this is by multiplying by the number 1. Okay, when you multiply by 1, you know that you don't change the value. And when you're doing these trig identity proofs or in any other kind of math, if you're working with something, you cannot change its value, but you can change what it looks like. So I'm going to kind of give this cosmetic surgery. I'm not going to change its value, but I am going to change the way it looks. And the only way you can do that is multiplying by 1. But 1 comes in lots of different varieties. So this 1 is going to look like, so we'll put a star there for multiplication. We're going to focus on this, the one that has the two terms with an addition or subtraction sign. In this case, it's a plus sign. We are going to multiply top and bottom by the conjugate of this. Conjugate means same thing, opposite sign in between. So I'm multiplying top and bottom by 1 minus cos x. This is simply just the number 1, but it's written a little bit different. It's not written like this. Okay, it's written as an expression, but anything divided by itself is 1. All right, things that don't look alike, don't multiply them together. So the numerators have nothing in common, so just leave them as is. Okay, don't do anything with that. With the other ones, however, this is a binomial times another binomial. They are exactly the same, except one has a plus sign and one has a minus. That is the difference of squares. When you multiply this out, you will be left with 1 minus cos squared x. Now I know another name for this. Okay, and remember, keep looking at this side because that's where we want to get to, and we're almost there. Leave the numerator alone. Okay, so keep it as sine x times 1 minus cos x. Then down on the bottom, we just said 1 minus cos squared x is the same thing as sine squared x. So do that little replacement. This is all multiplying and dividing. A number times another number divided by another number. When you have a situation where it's all multiplying and dividing, anything on top can cancel with anything on the bottom. This sine x will wipe out one of those. And that leaves you, so this is 1 through that bracket, so now get rid of the bracket, and we will have 1 minus cos x. And then on the bottom, you're just simply left with one of these sine x's, and a quick look, this is our left side. So again, we started with the one side, in this particular case the right side, and we turned it into the left side. And that's what 99% of all your proofs will look like. All right, so I hope this helps. And again, send me any comments if there's other things that you want to see. All right.